SQL Server 2022 has introduced an exciting feature called Parameter Sensitive Plan Optimization, or PSP optimization for short. This innovative capability really stands out. It allows the database engine to cache multiple execution plans for a single parameterized query, especially those that involve equality predicates. In this lesson, we're going to explore how this feature enhances query performance and boosts the overall efficiency of your database. So far, we've learned about the query execution process in T-SQL, focusing on the crucial role of the relational engine, which handles parsing, optimization, and execution of SQL commands. Remember, we talked about how parsing checks the syntax and semantics of SQL statements, while optimization is responsible for generating execution plans, to determine the most efficient ways to execute our queries. We've also explored things like the significance of indexing for performance improvement, the various types of joins, and the important need for robust error handling and execution plan analysis. Overall, having a solid grasp of these concepts is essential if you want to write optimized T-SQL code and enhance your database's performance. Now let's dive into the details of parameter-sensitive plan optimization, its benefits, when you might want to use it, and of course, we'll check out some code examples to see it in action.
Next, we will write a simple SQL query that retrieves customer data based on a specified country. The query specifically looks for records in the customers table where the country field matches the parameter @country. Now, you might be wondering why parameterization is so important. Well, it's crucial because it allows SQL Server to optimize how the query executes by creating different execution plans based on the actual country you provide each time you run the query. By using parameterization, the database can save tailored plans for different customer distributions, which ultimately leads to better efficiency and performance, especially when this query runs multiple times with different values of @country. For example, if the query is first optimized for @country equals USA, it creates a specific execution plan that's highly efficient for pulling data on customers in the USA. But if later on you run the same query with @country equals Canada, thanks to parameter-sensitive plan optimization, SQL Server can pick a different plan that's optimized for how customers are spread in Canada. This flexibility really shows the power of PSP optimization and, in turn, improves the response times of the query across different parameter executions. Now, let's dive into how we can implement parameter-sensitive plan optimization, or PSP optimization, in our SQL Server environment. The first step involves enabling this feature, which we do by using the Alter Database Scoped Configuration command to set Parameter-Sensitive Plan Optimization to On. This configuration allows SQL Server to maintain multiple cached execution plans for parameterized queries. Pretty cool, right? It significantly enhances performance, especially for queries that involve equality predicates. Next, we'll create a stored procedure designed to fetch order details based on specific start and end dates, as well as a region. So let's define our procedure, and we'll name it Get Orders by Date and Region. We'll establish parameters for the start date, end date, and the region. Within the body of the procedure, we run a select statement to pull data from the orders table, filtering according to the parameters we provided. This method allows SQL Server to generate and cache execution plans that are tailored to the changing values of the @region parameter, really optimizing the query's performance for different regions. Through this approach, the flexibility and power of PSP optimization become evident in practice.
The figure displays a dual-bar comparison across 5 countries: the USA, Canada, the UK, Germany, and Australia. For each country, the blue bars represent execution time in seconds, while the orange bars illustrate performance improvement as a percentage. Now, from the plotted values, we see execution times ranging from 1.5 seconds for the USA to 2.5 seconds for the UK. On the flip side, the reported performance improvements span from 10% in the USA to 15% in the UK. There's a noticeable pattern here. Countries with higher baseline execution times, like the UK at 2.5 seconds and Australia at 2.3 seconds, are also showing larger percentage improvements of 15% and 13%, respectively. Meanwhile, the USA, which has the lowest execution time at 1.5 seconds, corresponds to that smaller improvement of just 10%. This alignment suggests that parameter-sensitive plan optimization, or PSP for short, tends to provide proportionally greater benefits where the original execution plan was more costly. Isn't that interesting? And the good news is every country in this figure benefits to some degree, as all improvements fall within the range of 10% to 15%. This demonstrates a consistent positive impact across regions. The chart's dual y-axes and color-coded legend make it absolutely clear that we're comparing absolute cost in seconds against relative gain in percentage terms. So we can conclude that PSB is particularly effective at reducing the relative performance burden, especially in those cases where execution times are at their highest. Now let's take a moment to explore how to retrieve information about cached execution plans in SQL Server, shall we? The query we're going to use starts by selecting the type of cached plan, the associated query plan, and importantly, the number of times each plan has been executed. Here we tap into the SYS exec cached plans dynamic management view, which gives us access to the query plans stored in memory. By employing a cross-apply with the SYS exec query plan function, we can directly pull out the execution plan details that correspond to each cached plan. Now, in the where clause, we're filtering the results to focus on plans categorized as ad hoc or compiled. This distinction is critical since it helps us target the relevant plans generated during the execution of parameterized queries. And to make things neat, we order the results by execution count in descending order. This way, we can quickly see which plans are put to use the most. This analysis is essential for checking if the parameter-sensitive plan optimization feature is effectively caching multiple plans for a single parameterized query. Another critical aspect to be aware of when working with parameter-sensitive plan optimization is its interaction with other optimization features. For instance, let's talk about the idea of optimize for ad hoc workloads, which can really shine in large environments where you have a ton of ad hoc queries. Now, when you enable this feature, SQL Server optimizes by caching just a single plan the first time a query is run. This in turn significantly cuts down memory usage for those queries that aren't reused often. But here's the thing, if you're leveraging PSB optimization, enabling this feature might lead to some, let's say, inefficiencies when it comes to maintaining multiple plans. So the decision on when to use these features really should hinge on the specific workloads and the execution patterns you encounter in your environment. Now let's take a look at a practical application of parameter sensitivity with a temperature conversion stored procedure. In this procedure, we define two parameters, at degrees, which is a floating point number representing the temperature value you want to convert, and at scale, which is a single character indicating the temperature scale, either Celsius or Fahrenheit. The logic inside this procedure starts by checking the value of the at scale parameter. If it is C, the procedure calculates the equivalent Fahrenheit value using this formula, at degrees *9/5 plus 32. That converts the input Celsius temperature to Fahrenheit. Conversely, if the scale isn't C, it assumes the input is in Fahrenheit and converts it to Celsius using the formula at degrees 32, 5/9. This design nicely illustrates an efficient use of conditional logic, allowing the procedure to dynamically respond to user input, optimizing performance by ensuring that the correct conversion calculation is executed based on the scale passed in. Now, here's a cool part. When combined with parameter-sensitive plan optimization, SQL Server is smart enough to cache different execution plans based on the various values of at scale. This means it can enhance overall query performance across a broad range of user inputs. To wrap up this informative discussion, let's reflect on the remarkable capabilities that parameter-sensitive plan optimization, or PSB optimization, brings to the table. Not only does it enhance performance, but it also simplifies the development and maintenance of parameterized queries. Yeah, that's quite a win. Now, as your application scales and more users begin querying your database at the same time, the optimization offered by caching multiple plans can truly mean the difference between smooth user experiences and those frustrating delays we all dread. For those practitioners eager to incorporate PSB optimization into your processes, remember this: keep an eye on plan cache usage and regularly assess execution plans. With the right configuration and diligent observation, you'll ensure that your parameterized queries are performing optimally. This means they'll be meeting performance expectations and achieving smooth query executions, no matter what parameter values are being utilized. Now, as we illustrate the results of our explorations, keep in mind that the flexibility and power inherent in SQL Server's parameter-sensitive plan optimization feature is not merely a luxury, it's becoming a necessity in today's data-driven applications. So, embrace this feature, dive into performance metrics, and continue to develop an understanding of how it can be a game changer in your SQL Server environments. Whether you're crafting complicated stored procedures or executing simple queries, the enhancements brought by this feature will put you on the right path to optimized performance and efficient database management. With that, let's conclude this segment and prepare for our next discussion, where we will delve deeper into advanced indexing strategies to further bolster query performance in SQL Server.